This is Mrs. Downey, and this is Algebra 2, Chapter 3 Review over Linear Systems. Our first problem says solve the system by graphing. So when we do the first equation, we have, notice that they're both in standard form, ax plus by equals c. So you could just graph the x and y intercepts and find your intersection there to find your solution. But my graphing software didn't handle that, so let's put them both in slope-intercept form. So the first thing I'm going to do is let's work on this second one here. So what am I going to do? Solve for y. I want to put them in slope-intercept form, y equals mx plus b. So I'm going to subtract 3x from both sides. So I get minus 3x. And then I'm going to divide everything by a negative 1. So that goes to positive, that goes to negative, and this goes to positive. Okay, so I end up with y equals 3x minus 10. So when I graph this, I've got a y-intercept of negative 10, which I've shown right there, and I've got a slope of 3. So from that point, I'm going to rise 3, 1, 2, 3, and run 1, and plot that second point. When I do, and I graph the line, I get that. Now let's look at our first equation. So I've got negative 3x minus 2y equal negative 7. So let's put that in slope-intercept form. So add 3x to each side. Divide everything by a negative 2. Okay, and we get that y equals, and let's put x first, a negative, because I've got a positive over a negative, so it's going to be negative 3 halves, which is 1 1/2, x, and these signs cancel out, so I've got a positive plus 7 halves, which is 3 1/2. Okay, so let's plot this y-intercept. This y-intercept is 3 1/2. So we're going to go up to, let me turn on my numbers, 3 1/2, so about right there. And I've got a slope of negative 1 1/2. So it means I'm going to go down a half, down a full, so there's 1 1/2, and over to the right 1, and plot that second dot. Okay? So again, it was 3 1/2. And down 1 1/2 and over 1, right there. So when we connect these two lines, we're going to get something like this. And we know that the solution of our system is where they intersect. So let me turn off the numbers and let's count this out. So it looks like we're at 1, 2, 3, and down 1. So the solution of our system is 3, negative 1. So that is the answer to our solution. Now to check this for sure, we would plug in 3 for x and negative 1 for y and see if it makes a true statement. So if we plug in a 3 there and a negative 1 there, well, we get negative 3 times 3, which is negative 9, and negative 2 times negative 1 is a positive 2. Negative 9 plus 2 is a negative 7. Negative 7 does equal negative 7, so that checks. Okay, and you would do the same thing for the next equation. 3 for x, negative 1 for y. So you have 3 times 3 is 9. Negative times negative is positive. So 9 plus 1 is equal to 10. So that checks out as well. And that's the solution to our system. Our next problem says a jet ski company charges a flat fee of $27 plus $2 per hour to rent a jet ski. Another company charges a fee of $16.50 plus the $3.75 per hour to rent the same jet ski. So we've marked out using a graphing calculator. We want to do this by hand. So find the number of hours for which the costs are the same. So we want to know when they are equal to each other, right? When is the cost the same? Well, what does it cost? Well, let's look at the first thing. And actually, let me do this. The first one, it says the first jet ski charges a flat fee of $27 plus $2 per hour. All right, so let's write that in equation. Y equals $2 per hour. Remember, when it says per, that's your x value. That's your slope. Something dollars per hour. That's a slope. That's a ratio. Dollars per hour. Okay, that's a slope. Some kind of ratio. So we know that's going to be our x value. Right? So that's going to be 2x. So $2 per hour plus a flat fee of 27. So remember, that's that y-intercept part. So if I don't even rent it even 1 hour, I have 0 hours, that still means my flat fee is going to be 27. That's always that y-intercept, right? So there's our first equation. Now our second equation says another company charges a fee of, well, let's call this one y2, we'll call that one y1, is equal to $16.50 plus $3.75 per hour. All right, so let's turn that around. So the 3.75x dollars per hour plus the flat fee of $16.50. All right, so now we've got our two equations. This is the first company's and this is the second company's charges. So they want to know when, find the number of hours for which the costs are the same. Well, they just want to know when are the costs equal to each other. So that would be like, well, when is the first company's charges equal to the second company's charges? So let's just substitute here. What is y1? 2x plus 27. What is y2? 3.75x plus 16.50. Okay, so now that we have this, now we can solve for x and continue. So the first thing I'm going to do is subtract 3.75 from each side, 3.75x. Right. Okay, and when I do that, I get a negative 1.75x there, and this goes away. Okay, now let's put our constants on the other side, so subtract 27 from each side. And then this goes away, and I get negative 10.50 over here. So now I need to divide each side by negative 1.75, and I get that x is equal to 6. So there's your answer. At 6 hours, they are the same cost. Problem 3 says solve the system by substitution. So the first thing we're going to do is figure out which equation we want to solve for one variable. So let's just do it with the first one, and let's just solve for y. Right? So what are we going to do? Add 2x to each side and divide everything by a negative 1. So that goes to a positive, that goes to a positive, and this one goes to a negative. So rewriting this equation, we have y equals negative 2x plus 14. So we're going to take everywhere we see a y in the next equation, we're going to replace it with negative 2x plus 14. Right? So that would be our substitution. So we're going to go 3x minus our y, which is negative 2x plus 14, equals 11. So now we're going to distribute. That's like a negative 1 there. So we're going to have 3x. Negative 1 times negative 2x is a positive 2x. And negative 1 times 14 is negative 14 equals 11. So now we're going to combine our like terms. 3x plus 2x is 5x. And let's add 14 to each side to keep solving for x, right? And when we do that, this goes away. And that's plus 14. So we have 5x equal 25. Now divide each side by 5. And we have that x equals 5. So we've got half of our equation. We've got the x part. And it's 5. Now we're going to plug that back into either equation and solve for y. So let's just use our first one. So if x is 5, right? So this becomes negative 10 minus y equal negative 14. And adding 10 to each side, I get negative y equal negative 4. Now, divide each side by a negative 1, and I get y equals a positive 4, which is my answer. And you would plug 5 in for x and 4 in for y into both equations and make sure they make true statements. This is your answer. The next problem, number 4, says solve the system using elimination. So that means we're going to add or subtract these two equations to eliminate a variable. And when I look at all these, well, I cannot add or subtract and get rid of my x's. I can add and get rid of my y's. So let's do that. So adding these, this is going to go away. And I get negative 4x plus x, which is negative 3x, equals negative 8 plus negative 7 is a negative 15. Divide both sides by negative 3, and I get that x equals 5. So I've got half my equation. Now I'm going to plug 5 back into either equation. For x, I'll use the second one and get my y. So I have this one, x, which is 5 minus 4y equal negative 7. So now I'm going to subtract 5 from each side, and I get a negative 12 over here. Divide each side by negative 4, and I get that y equals a positive 3, because the signs cancel out, and 4 goes into 12 3 times. So there's my y, and when you plug x and y back into both equations, it will make a true statement. So my answer is 5 and 3. My next problem, number 5, says a group of 36 people attend a ball game. There were twice as many children as adults in the group. Set up a system of equations that represents the number of adults and the number of children who attended the game, and solve the system to find the number of adults and the number of children who were in the group. So let's let C represent children, and let's A represent the adults. So it says there's 36 people total. So let's work on the total, the numerical part of this. 36. And what is it representing? What does that equal? Well, the number of children who attended, so C, and the number of adults who attended. So there's the first part of your system. Now it says there are twice as many children as adults. So the number of children equal twice the adults. And there's your system. Okay? So how do we solve this? Well, by substitution. And so we've got already one variable solved for here with c equals 2a. So in the other equation, in the first equation, everywhere we see a c, we're going to replace it with 2a. Right there. So let's do that. So we've got 36 equal c, which is 2a plus a. Right? And now 2a plus a is 3a. So 36 equal 3a, divide each side by 3, and we get the a equals 12. So the number of adults is 12. All right, now how many children? It said, well, the children is twice the adults. So that means the number of children must be 12 times 2, which is 24. And that's your answer. 12 adults and 24 children. Problem 6 says solve the system of inequalities by graphing. Well, notice that both of these are in slope-intercept form. And the first one says y is less than or equal to negative 3x minus 1. So we have a y-intercept of negative 1. Right here. And we have a slope of negative 3. So I'm going to go down 3 and over to the right 1 right there. And that creates this line right here. Okay? So that's the first line graphed. Now it's less than or equal to, so it's a solid line and it's shaded below. Okay. Now the second line, we've got a y-intercept of negative 2 and a slope of 3. So from negative 2, we're right here, and a slope of 3, so we're going to rise 3 and run 1. It's the second line right here. But it's just greater than, not equal to. So this becomes a dashed line. So let me get my pink and we'll dash this. Okay. And it is greater than, so it is shaded above. So the part where these overlap is going to be here, and this dashed line here, and it's everything in between, forever and ever. But remember, this stays a solid line in your intersection, and this one down here stays dashed. Okay? And that's the solution to your system, the overlap of these two. In our next equation, number 7, we've got a system to graph here. And it says x is greater than or equal to 2 and y is greater than negative 1. So let's graph this real quick. So if x is greater than negative 2, greater than or equal to, one more time. If x is greater than or equal to positive 2, we're going to go to our x-intercept and draw a line through 2, right there. And it's a solid line because it's also equal to 2. And it's greater than, so we're shading above. So there's there's 1, there's 2. All right, now the next one, y is greater than -1. So we're going to go to the y-axis. We choose a different color and go to -1. And we're going to put a line through the y-axis at -1, but it's just greater than, so it's a dashed line. All right, and it is greater than, so he is shaded above. Okay, and so the overlap of these things right here is this dashed line right here, and solid line here, and everything in the overlap. And that's your solution. The next equation says solve the system of inequalities by graphing. So the first thing we have is y is greater than or equal to x. So we know that that's going to be a line that goes through the origin. There we go. And it's solid because it's also equal to, and it's greater than, so we know it's shaded above. So this is what we are graphing here. Now the next line that we're graphing says y is greater than, well, it's an absolute value thing, right? And it is stretched a little bit, so 2x, and then the plus 2 means it's shifted to the left 2, and the -5 means it's shifted down 5. So we're going to have some kind of absolute value function shifted to the left 2. So let's say if it was here, right? And if it shifted to the left 2 and down 5, we're going to be having the vertex down there. So let's see if I can do that. Almost. Moved a little bit more. But we've got this situation. Now it's greater than, not equal to, so we know it's going to be a dashed line. So let me rewrite this in blue. So it's going to do something like this. Right? And it's going to be, let's see, it's greater than, so it's shaded above. So where do they intersect? Well, it's going to intersect solid line right there to a dashed line right here, right, and everything in between. Okay, so you'd be picking something out like that. So it's not a perfect V, it's sort of a crooked V. Okay. So that's what that one looks like. And remember, you're picking from multiple choice answers. So you want to look generally at, okay, how should this be shaded? Where should this vertex be sitting? What quadrant should these be in? And you could probably start eliminating a lot like that. And then if you have to get down to fine details, plug a few values in and check it out, right? But you probably won't have to get to that. All right. Our next problem says solve the system by elimination. Elimination is the one where you add or subtract two equations to eliminate a variable. So this is a system of 3 equations. We're going to call this equation 1, equation 2, and equation 3. So I can better reference these. So what we want to do is we want to look at all of our variables. So the first thing I see, I've got some x's, and I cannot quickly add or subtract and eliminate variables. More here and more there for z. So nothing's quite as simple as we want it to be. We would love for all those to be all coefficients of 1, right? So it looks like we're just going to have to pick one and go with it. So I'm first going to use equation 2. Let's see. I'm going to first use equations 2 and 3, and I'm going to eliminate a z. Okay, so let's eliminate our z's. So for the first thing I'm going to do is write them. So equation 2, I'm going to have 2x plus y plus 3z equal negative 4. And equation 3, I've got negative 3x minus 3y minus 3z equals 6. So that was just a straight copy of both of those. Okay. Now I'm going to have to add these to eliminate my z. Right? So when I add these, I get a negative 1x, which is negative x, and then this is going to be negative 3y plus y is a negative 2y equals 6 minus 4 is a 2. So now I've eliminated my z out of equations 2 and 3, and I'm going to call that equation 4. Now I've got to work with my first equation, and I've got to eliminate my z. So I am going to use my first equation and my third equation. So let's do that. So I'm going to use x plus 3y plus z equal negative 6, and negative 3x minus 3y minus 3z equal 6. But if I add these right now, I can't get rid of my z. So what do I have to do? I have to multiply my first line by 3. So when I do that, I get a, let me clean it up, I'm going to get a 3x plus 3 times 3 is 9y plus 3z equals negative 6 times 3 is 18. Now I can add and eliminate my z. So I end up with, well, my x's go away as well, right? And now I have 9y minus 3y is 6y equals, and negative 18 minus 6 is negative 12. So now I can continue to solve, and my y is equal to negative 2. So I've got one of my answers right now. Y equals negative 2. So I'm looking for an x, a y, and a z. So I'm actually going to erase these right here. I'll leave my equation 4. And I'll get rid of all of this. So we know that my y is equal to negative 2. Okay. So now I'm going to plug in my negative 2 into equation 4. And I can do that because I already eliminated a variable and solved, right? So now I've got my x, so now let's just plug it into equation 4 and get our y. So we've got negative x minus 2 times y, which is negative 2, equals 2. So now we have negative x. Negative 2 times negative 2 is a positive 4, equal 2. Subtract 2 from each side, and I get a negative 2. And divide both sides by a negative 1, and I get that x equals a 2. So now I've got my x and my y. So now all I have to do is plug in x and y into my first three equations, any one of them, and I will have my last variable z. So I'll just choose my first equation, x plus 3y plus z equal negative 6. So I'm going to plug in a 2 for x and a negative 2 for y and solve for z. And I get 3 times negative 2 is negative 6. Negative 6 plus 2 is a negative 4. So I have negative 4 plus z equal negative 6. Now add 4 to each side, and I get z equals negative 2. So now I've got my last variable of negative 2. So number 9, the answer is 2, negative 2, negative 2. And when you plug each one of those back in for x, y, and z, all equations become true. Number 10 says solve the system by substitution. So they made this quite easy because they gave us one already solved for a variable, z. So that is our hint that in the other two equations, everywhere there's a z, we're going to replace it with a 5. Right? And when we do that, we can solve. So we get 2x minus y plus 5 equal negative 4. Now subtract 5 from each side, and we get a negative 9. So in our first equation, we get 2x minus y equal negative 9. Now let's fix our next equation here. So we get a negative 5, so add 5 to each side, and we get a negative 5. So rewriting this equation, we're going to get a negative 2x plus 3y equal negative 5. So that was our equation 4. That's our equation 5, for those of you keeping track. And now, let's clean this up a little. And there they are. Now we've eliminated our z variable. Now let's combine to eliminate again. So notice that if we just add these on equations 4 and 5, which I'm going to erase that, what happens is my x eliminates. So now I'm going to do that. So I get 3y minus y, which is a 2y equal negative 14. And so y is equal to negative 7. So I have my z's already given to me, right? We're looking for an x, a y, and a z. So we've got z is 5. They already gave us that. We just got our y, which is negative 7. And now we just have to plug those two back into either equation to get our x. So let's do that. I'm going to choose our first equation, 2x minus y plus z equal negative 4. And I know that my y is a negative 7, and my z is a 5. So let's rewrite that. 2x, so negative and negative goes to positive 7 plus 5 equal negative 4. Now, 7 plus 5 is 12. Then subtract 12 from each side. And what do we get? Negative 16. So I now have 2x equal negative 16. So x is equal to negative 8. So that is our answer. Negative 8, excuse me. Our answer is negative 8, negative 7, and 5. And that's how we solve our system by substitution. Our last problem, number 11, says a candy store makes a 12-pound mixture of gummy fish, candy hearts, and gumdrops. So let's let the gummy fish be X. Use my hot pink there. X. Let's let the candy hearts be Y, and let the gumdrops be Z. Okay? The cost of the gummy fish is $2 per pound. So we know the gummy fish is $2 per pound. So gummy fish is our X, right? So the gummy fish is $2 per pound, so it's going to be 2X. We'll let X represent the number of pounds. So candy hearts are $2 per pound. So our candy hearts is Y, so again, 2Y. And gumdrops are $1 per pound. So now we've done all that. So our gumdrops is Z, so 1 times Z. Well, what does all that equal? We're talking about money here. It says the cost of the mixture is $20. So the $20 is equal to this money. So $2 times the pounds of gummy fish, $2 times the pounds of candy hearts, and $1 times the pounds of gumdrops. Now, let's go back to the first statement. They said they make a 12-pound mixture. So we know that the 12 pounds are made up of what? The pounds of gummy fish, which are X, plus the pounds of candy hearts, which is Y, plus the pounds of gumdrops, which is Z. So now we have 2 of those in our system, but we know this is going to be a 3-system equation because they gave us one more thing to work with. What did they tell us? They said the mixture calls for 3 times as many gummy fish as candy hearts. So the gummy fish were X and the candy hearts are Y. So we have 3 times the amount of gummy fish as candy hearts. So that means the gummy fish, which is X, is equal to 3 times the candy hearts. So there's our system with 3 variables. Okay? So there's the first part, is we just have to create the equation. So we can tell right away that this is going to be a substitution problem because we have X is equal to 3Y. So what we're going to do is replace that in our other equations. So let's work with the first one. So we're going to have 20 equal 2 times X, and we said X is equal to 3Y, so we're going to replace that X with the 3Y, plus 2Y plus 1Z. Alright, so there's our first equation. Now let's solve it. So this is going to be 6Y plus 2Y plus Z. 6Y plus 2Y is 8Y plus Z. So we have 20 equals 8Y plus Z. So there's our first problem. Now let's do the same thing for our other equation. 12 equals X plus Y plus Z. And we said that X is equal to 3Y. So we're going to replace X with 3Y. Okay, so 3Y plus Y is 4Y plus Z. So we have 12 equals 4Y plus Z. So there's our next equation. So we have what we called equation 4 here and equation 5 there. Now we want to combine equation 4 and 5 and try to eliminate one more variable. So we're going to have 20 equals 8y plus z. And we're going to have 12 equals 4y plus z. So what we need to do, we can eliminate a z if we multiply everything by a negative 1. Let's do that on the bottom, right? So when we do that, we get a negative 12. It's just going to flip every sign. So let's do that. So you get a negative z minus 4y and minus 12. So when we add these, we're going to have 20 minus 12, which is 8, equals, and now we have 8y minus 4y, which is 4y, and the z's eliminate. So now divide each side by 4, and we get that y equals 2. So now we know there were 2 pounds of y, which are our candy hearts. So we have candy hearts is equal to 2 pounds. Right? That was our y. Now, let's go back and get the rest. Well, we know that our x is what? 3 times y. And if our y is 2, then we have 3 times 2, which is 6. So an x was our gummy fish. Okay, so that leaves us with z, our gumdrops. So we could scroll through here and find an equation that has z equals something, but we don't have that, right? So let's just plug it into one of our original equations. How about this one here? 12 equals x plus y plus z. And let's solve for z. So we know that 12 equals, let me choose a different color. 12 equals x, which is 6, plus y, which is 2, plus z. Now 6 plus 2 is 8. Subtract 8 from each side, and you get a 4 over here. So z equals 4. And that's our last one. Z was the gumdrops, which is equal to 4. So we have our final answer right there. There are 2 pounds of candy hearts, 6 pounds of gummy fish, and 4 pounds of gumdrops. And that concludes our last problem and our study guide for our Chapter 3 test. Thanks for watching, and study hard.